Despite a 26-year history, Java is still being actively developed. And as for a language so mature, the number of new features added with each release is usually quite impressive. Putting it on top of a 6-month release cycle, yes, every half a year Java gets a new version, we get a constantly evolving, rapidly changing language. In this episode, we'll go through the most interesting features added to the language in the last few years. Between Java 9, released in 2017, and Java 17, released in September 2021. The classic switch we have in Java inherited its syntax from C++, and well, it's not a very good syntax. We've all been using it for a long time, but it has its flaws. Here we have a very simple switch. We take a player's name, and depending on the name, we print out his club. Let me see what name we put here. We put Lewandowski. So in this case, we should see Bayern here in the terminal. Yes, and we have Bayern. It seems alright, but the syntax of switch, the switch we have used for so long, is not very clear. We have those breaks here. And what happens if I remove the break, or I comment out this one and this one? Let's run it again. Now we have Bayern, PSG and Manchester United. If we put Messi here, the output will be PSG and Manchester United. This is because switch works in a way that it finds the first matching case, it executes the statement which is associated with this case, and then it executes all the statements below unless it finds a break instruction. So we have to put these breaks here to make it really work. It's not the best way, it's not the best syntax because it's very easy to make a mistake here. It's also not very clear when we look at the code, and creators of Java also were aware of that, and that's why they decided to change this switch in newer versions of Java. And now let me close this, and you can see here that IntelliJ is already suggesting me the change. It says that the switch statement can be replaced with enhanced switch. So let me press Alt Enter, replace with enhanced switch statement, and here we are. Here we have a new switch. We have several cases. The first case, Lewandowski, Müller or Neuer, and the instruction that should be executed. So we have an arrow here and then the instruction. We don't have any breaks here. It's just a simple construct. We have several cases, and if we have a match, we just execute what's associated with that case. We don't have that weird logic that we execute the associated statement and all the statements below. So a very good change, and this is the switch I really recommend. The next thing, a new instance of. We have a very simple structure here. I have created this abstract file class, which is abstract, and I have also created two classes that extend that abstract file. This is music file, which has one method play music, and video file that has a method play video. So now we go to the instance of example. Here we can see that I have created a new variable, abstract file. I gave it a type of an abstract file, but I gave it an instance of a music file. So now here we can use the instance of operator. If abstract file is actually an instance of a music file, how did we do it before? So what we usually did was to cast this abstract file to the music file, and now we can use the method play music, which is a part of a music file class. This looks quite okay, but it might be better. Inside if we already know that abstract file is actually a music file, so why do we have to cast? In newer versions of Java, we don't need to cast it anymore. So what we do instead, we do like this. So first part is the same. We check if abstract file is an instance of a music file, and here we give a name for a new variable. If this is true, let's create a new variable called music file. And now this variable will be present inside our if. So just like this. Java is a statically typed language, so every time we initialize a new variable, we must declare its type. But in Java 10, a new feature called type inference was introduced. Now, instead of writing a type, we can write var, we can give a name, and we can initialize a variable, and a correct type will be inferred by a compiler. Of course, it works only when we initialize a variable. It won't work in a case like this, when we first declare a variable and we want to initialize later. It won't work. It also won't work for class fields, so doing like this also won't work. An interesting thing is that var is not a new keyword. It doesn't work like the other keywords that are reserved, that we can't use them in a code. We can do something like this and it will still work. Of course, it's not the smartest way to write a code, but it's technically correct. This is because of the backward compatibility. The creators of Java couldn't have added var as another keyword because it could have messed some code which already exists. The feature itself might not feel very impressive, but of course, I mean, these examples are really simple. There's not much of a difference between int or string and var, but if we have longer class names, it might make a difference. The next feature, records, is something we know from other programming languages under the name data class. A data class, as the name suggests, is a class that holds data. It doesn't contain any logic, it doesn't calculate anything, it just holds the data. Before records, if you wanted to have a data class in Java, you either had to write a lot of code, a lot of boilerplate code, or you had to use some library like Lombok. Let's see how much code I'm talking about here. So let's create a class, call it a person, and we'll have two fields here, private final string name and private final int age. Of course, we need a constructor, so we generate one. On Windows, it's Alt Insert. On macOS, it's Command N. We have this generate window, so I'm choosing constructor, and here we have a constructor. But of course, we need getters for our fields, so let's generate those. Name, age. Okay, already 19 lines of code, but it's not the end. We usually want to compare objects of such a class, so let's generate equals and hash code like this. Okay, it's getting bigger. And let's generate toString because we want to have a good text representation of an object. Okay, 42 lines. How can we achieve the same using records? Creating a new Java class, person record. Here I'm choosing record. And I'm giving the names and types of these two fields, string name, int age. And that's all, 4 lines of code. How can we use it in our code? Actually, we use it as a usual class. It's almost the same. First, let's create an object of class person, my name, my age here, person1, and now let's use the record. And that's it. The only difference here is how we access the fields. In the case of a class, we use our getter. In case of a record, we just give the name of the field. And that's all. Let's compare once again. This is our class, a lot of code. Here we have record, very short, very concise piece of code, no room for error here, and this is what makes records really special. And I think it's one of the best features that was introduced in Java in the last few years. The next feature, handling multi-line strings. And this is how we've been doing this so far. So we have this string and we have a lot of different characters inside. We have those slashes t, slashes n's. It doesn't look very clear. When we look at this string, we actually don't know what it represents. When we want to have an indentation, we have to explicitly say /t. When we want to have end of a line, we have to put /n. When we want to have a quotation mark inside our string, we have to escape it using a slash. But now we can do everything much easier. We can use a new feature called text block. And this is it. We just put our text inside triple quotation marks and all formatting is preserved. So now when I run this, we see that we have a very nicely looking JSON. If I remove this indentation and run it again, we see that it's gone. So our string, our text looks exactly how we wrote it. And this of course leads to a code that is clear and easy to read. Now we have a very interesting feature called sealed classes. This new approach gives us more control over who can extend our classes. Let's start with a simple example. I will create a new class called audio file and I will mark it as an abstract class. And now I want to extend this audio file, so I will create an mp3 file that extends audio file. So this is the classic approach. We create a class and everyone can extend our class. But now with sealed classes, we can explicitly tell who can extend our class or who can implement our interface. So now we can add to the audio file a new modifier called sealed. And now IntelliJ tells us that there is an error, there is a problem, because we need permits clause, because we need to give an information who can extend our class. So permits, and I will give this mp3 file, but it's not all. Here we have another problem, because all sealed class subclasses must either be final, sealed, or non-sealed. So we go to mp3 file, and now we have to give it one of those three modifiers: sealed, non-sealed, or final. If we give sealed, we need once again permits here, because we need to have subclasses of this. So I want now to give it a final modifier, so no one else can extend this class. Now, if I gave non-sealed, everyone could extend mp3 file. But let's go back to final. If I wanted at some point create a class that extends mp3 file, like extended mp3 file, I would need to extend mp3 file, which is not possible at the moment because this is the final class. So I now have two options. I can do either this, non-sealed, so now everyone can extend, or I can put sealed, and now I can give permits here, and I can tell that extended mp3 file is allowed to extend this class, this mp3 file class. But now, of course, in extended mp3 file, I need to give a modifier. And now let it be final. And the same for interfaces. So let me create an interface called drive. And I want it to be a sealed interface. But now, of course, we need to have subclasses. Someone must implement this interface. So let me create a new class, HDD drive, which extends drive. And here we have actually two issues. First is that no extends but implements. So first, HDD drive is not allowed in the sealed hierarchy because we need to give a permit here, permits HDD drive. What else? Okay, all sealed class subclasses must either be final, sealed, or non-sealed. So we go back to HDD drive, and here we put a modifier. So let it be non-sealed. So this feature adds like a new level of control. We can explicitly tell who can extend a class or who can implement an interface. For a long time, initializing a collection in Java wasn't very convenient. This is how we had to do it with set. So first we had to create a new set, and then we had to add all elements manually. The same with map also. We created a map and then we had to call put several times. The same with lists, but here at least we had this syntax, arrays as list. So we could use this static method and initialize the list in one line. This wasn't the best solution though, because we had to know that such method as list exists in arrays class. Now all of this we can do much easier because we have of methods. And these are static factory methods to initialize a collection. So now instead of calling add or put several times, we just have list of, set of, map of, or map of entries. Much easier, much more clear, much better. The last feature for today, a very cool one called meaningful null pointer exceptions. I think everyone coding in Java knows that pain when we have a null pointer exception and we don't know what it's about. So I've created this very simple class, person class. It only has two fields, name and age, and I created an instance of this class in our main class here. By the way, I'm using this REPL-IT, an online compiler, because this has Java 11 and Java 11 didn't have those meaningful null pointer exceptions yet. So we will see a difference. Okay, we have an instance of a person class here and we call getName here and then we call toLowerCase on this name. In this case, everything will work because we have a name, so we can call toLowerCase on the name. And we can see that the name in lowercase was displayed. But now I will comment out this one and I will use this code. So we can see that I don't provide a name here, I provide a null. So here this getName will return null and toLowerCase will return a null pointer exception. It will throw a null pointer exception. So let's run it. Yes, and we see that in line 7 we have a null pointer exception. But what happens if I comment out this and run this? This time person class, the instance of a person class, is null. So not this is null, but this. Let's run it and we see that we have a null pointer exception in line 10. But we don't have any information where exactly we got this null pointer exception. We don't know if it was here or here. And this is not the case in Java anymore. Let's go back to IntelliJ. We have exactly the same example here. I commented out these two lines. I'm running. And let's see. Cannot invoke string to lowercase because the return value of meaningful null pointer exceptions person class getName is null. So now we know that null pointer exception came from here, from this getName method. And if I comment out this and I run this, we see that person 3 is null. So we have this meaningful null pointer exception. Now we know where to look, where we can fix the problem. That's all for today. Thanks for watching and have a good one.